Okay, let's start this. This is my second attempt. I'd forgotten to turn on my ladybug, and then it came up. It had an issue, and I dropped a inappropriate word. So let me try this again. This problem is not that hard. Okay, it looks hard when I first started. I was going, oh my, we're going to have to find out what the force is. But if we use static, if we know static equilibrium, it's not going to be that tough. This also kind of shows you the tension in her legs, and the force gets lighter and lighter as she gets lower and lower to the ground. Now she's off the ground. Her midsection there, her body is off the ground, and she's forming a small truss-like triangle here. Okay. And so here's how you set this problem up. And it's not that bad. Trust me, it is not that bad. So here we go. Essentially, you've got this. You've got a triangle that looks like this. CG is coming down here, her center of gravity. This is where mg goes. That's the force. And then this is where her feet are. Okay, let's make these even. Fairly even. That's not a very good isosceles triangle. So this distance is A, this is A, and this is 2A. Here, whatever those A's and 2A's happen to be for you. All right, now, let's look at this. Look what happens. We have a force that's coming up this way because she's pushing down that way. She's pushing down that way. So this is the force that her center of gravity is creating, and we've got a force coming back. We have to break that force down into its components. Okay? Well, first of all, we need this angle. We're going to deal with this over here. Okay? I'm going to deal with this one over here just because that's... So if I look at this force, which is going at an angle like this, it is going up. Okay? It's going up here, and it's going across this way. All right? Those are the two components of that force. This angle is equal to this angle. All right? The same thing over here, because I'm actually going to use this force here. Same thing over here. This is going up over here and going across over here. And this angle is the same as this angle. Well, what's that angle? Angle theta is going to equal the inverse tangent of h over a. Okay? Now, let's take a quick look at this point right here, where I have a force in the y direction going like this, and a force in the x direction going like this, which is actually probably much more. Force in the x direction is going like this. And so here's my force, okay? And we've already established that this is theta, all right? Okay, so let's redraw this line right here, this imaginary line. That's a legal move. Let's just draw this A2A right here, and I've got a force of the center of gravity coming through here, because it's a vector. I can place it anywhere I want, just as long as I keep the same magnitude and direction. I've got F of Y of the force on her toe. These are the forces on her toe going up like that. And I'm going to use this as my lever, as my pivot point, because I also have a force going up like this, F of Y. These two forces are equal. And I bet the other thing I could do is, and you might be going, well, wait a minute. Those two forces, these two forces will add up to mg. Okay? But wait, but that's not the force we're after. We're after the magnitude of this force here. We're after that force. So we've also got to know what the f of x is. Okay? But we're going to solve for f. Okay, we're going to solve for f here. All right? Because we're going to use, because the y component is equal to F sine of that angle that we found up here. Okay. So let's just go ahead. So now it breaks down. It's straightforward, pretty nice and simple. This is A, and this distance is 2A for this force, for the torque caused by this one. And so I've got the sum of my torques. She's not moved, she's not twisting anywhere, is equal to this torque is going this way, which is clockwise, so that's negative. So I've got minus mg times A. This torque is going this way, so that's counterclockwise, so that's a positive torque. This is a negative torque. All right, plus F sine theta, F sine of theta times 2A. And this equals 0. Well, I'll be. I know all this. I know all this except for F. We've got it. We are done. Okay? That'll do, pig. Say in pig, in babe. For me, I'm the pig. All right. Good job. Out here.